Alright guys, here goes nothing. This is Pre-Calc exam review, semester 1, part 1, S1, P1, Pre-Calc. Alright, number 1. So we have v squared plus 2 equals 8 minus v squared, right? So now we have to solve for v, or for v, I'm sorry. I can't read. Special shout out to Morgan for getting me these pictures so quickly. Alright, first thing I would do is add 4v squared to both sides. And I'd also subtract 2. I'm doing 2 steps in 1. Deal with it. That cancels. That cancels. 1v plus 4v is 5v squared equals 10. Equals 6. Math is hard. 8 minus 2 is 6. Divide by 5. Divide by 5. And we end up with v squared equals 6 over 5. And I square root both sides. And I get v equals plus or minus the square root of 6 over 5. There we go. That's number 1. Okay. Now let's do number 2. Hold on. Alright, I'm back and I did some magic. Alright, now we need to find the domain of these two beasts. Now, the only real concern we should have with this is I can't divide by 0 for number 2. The top, unrestricted, but the bottom can't equal 0. So I get x can't equal 9. So my answer is technically all real numbers, except x can't equal 9. Alright? Now for this one, number 3, we can't take square root of a negative, right? So I set this greater than or equal to 0, because it can be 0. I add x over. So my domain is 9 is greater than or equal to x. Alright? So far so good. Alright, now my next one I have a piecewise function. 9x plus 8 when x is less than 0. And it's 2x squared minus 2 when x is greater than or equal to 0. Alright, so what you do is you plug in 0 to each equation. So I do 9 times 0 plus 8. That gives me 8. So I have the point 0, 8, 2, 4, 6, 8. And it's an open dot, well, because it's not equal to. And it's less than, so I go to the left side and I draw my line. Okay, I'm just looking for a sketch here. I'm not looking for a precise graph. Now when I plug in 0 to the second part, I get 2 times 0 squared minus 2. That's negative 2. So I have the point 0, negative 2, and that one owns the fence. There's an or equal to below it. So I go 0, negative 2, I fill in the dot, and that's a 2x squared, so that opens like this. Just do a quick sketch. Alright? Alright, on number 5, I'm finding g of f of x, so I'm going to take f of x and plug it into g of x. In parentheses, 8 times x minus 5 over 8, because that's what f of x was, plus 5. 8's cancel. Negative 5 plus 5 is 0. So you actually got x. If you went the opposite way, you could find out if they're inverses. Alright, let's continue. Hold on, I gotta turn the page. Alright, now we gotta find the inverse, right? So I switch around my x and my y's. Then I solve for my y. So I'm going to subtract 4 from both sides. What just happened? What? Cube root both sides. So your inverse is y equals the cube root of x minus 4. Yay! Alright. To continue, Number 7. So our graph is y equals negative square root of x plus 2. We have to say what happened. Well, we're adding 2 on the inside. So if you're adding 2, you go the opposite. So you're going to the left 2 units. That's the horizontal movement. And now the negative is outside my function, outside the parentheses, where they would be, the implied parentheses. So that means I reflect over the y. They're in the parentheses, you reflect over x. So if it would have been square root of negative x plus 2, you reflect over your x. Alright? Uh-oh. No, my pen died. Alright. Charge that beast up. Alright. Number 8. Alright, I gotta pause this. Hold on. Alright, while my pen charges, I'm going to try to use a stylus on this screen. If you've ever used school laptops, you know that this is gonna be rough. So number 8. Ooh, so far so good. Number 8. When a number is added to its double and its triple, it equals 150. So far so good. Alright. So I'm gonna go through and x plus 2x plus 3x is 6x equals 150. Divide by 6 and you get x equals 25. Now that's not my final answer because it said find the 3 numbers. That one just refers to that x. So it'd actually be 25. 25 times 2 is 50. And then 25 times 3 is 75. Those were my 3 magic numbers. Alright? I'm going to continue with this tablet. It's working alright. Alright, so number 9. Number 9, it wants it in quadratic vertex form. So that's x minus h squared plus k. Now, you could do, completing the square, you could do h as negative b over 2a because that's your axis of symmetry. Right? So if you look at our function, our b was 4 and our a was 1 because it's x squared, so 2 times 1. So our h is negative 2. Alright, so we're going to have x minus negative 2 squared plus something. Now to find k, I take this and I plug it into my original equation. So I plug it into negative 2 squared plus 4 times negative 2. Get out of my way, toolbar. Get out of here. Alright, I'm just going to write below here. It wins this round. Plus 7. When I plug that all in, that's 4 minus 8, 7, so it's negative 1, 3. I got 3. 4. Anyone disagree? So I go plus 3. That's my k. Alright. We good? Good. Great. Grand. Alright. If I'm making mistakes, just let me know. It's fine. Alright, number 10. Is it a polynomial? State degree and leading coefficient. Well, yeah, it is. Yes. The degree is the highest degree it is, so that's 6, 11, or the leading coefficient is 11. Alright? Alright. Alright, so number 11. The height of a cone with fixed value varies inversely as the square of its radius. So inverse means, so I have my height varies, so equals. Inversely, so I put that on the bottom. Now it's the square of my radius, and then you always throw your k on top. That's a weird k. Okay. That whole fixed volume you have to do that to make the equation work. That'd be your constant. You could technically put b on top of it. Oh well. Alright, next slide. 12. Find your zeros and multiplicities of each. So I have negative 4x squared times x minus 9 times x plus 4 third. So this one, my 0 is 0 with a multiplicity. That means the power it's being taken to of 2. This one's 9 is my 0 with a mult of 1. And this one, my 0 is negative 4 with a mult of 3, because 3 is the power it's being taken to. Alright? 13. Synthetic division. Should we use long division? Alright, so 13. You guys can see the problem. So I put my negative, I go opposite of what I'm dividing by up in that box. Then I put my coefficients. No placeholders needed on this one. Bring down the 2. 2 times negative 1 is negative 2. 3 minus 2 is 1. 1 times negative 1, negative 1. 4 minus 1, 3. 3 times negative 1, it's negative 3. Negative 3. Negative 10 minus 3 is negative 13. So this becomes 2x squared plus x plus 3 minus 13 over what I was originally dividing by. Okay. Okay. Alright, this one you want end behavior for horizontal asymptote. You want to use limit notation. 2 ways to do it. You could graph it. Oh man, what's it? This graph look something, there's like a parabola in it. But I don't care about that. It did something like this and something like this, right? So you could look at it and say, well, I approach 0. 0 is my horizontal asymptote. Or you could use your power rules. Remember when you look at power, if the power on the top is smaller than the power on the bottom, your asymptote is y equals 0. If they're the same power, you use leading coefficients. If the power on the top is bigger, you have an oblique asymptote. Okay? So now for this one, because I know it's y equals 0, my limit as x goes to infinity of f of x. So as I go on forever, this direction, I get closer and closer to 0. I have to deal with both. Scroll up. And then I also need to do limit as x approaches negative infinity of f of x. So as I go to the left, I get closer and closer to 0. So that's using limit notation to describe my end behavior of the horizontal asymptotes. Woohoo! Oh, this one's a doozer. Does this have hand protection? I wonder. I'm going to try it. Ooh. Nope, 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 it doesn't. Alright, so I do 6x over x minus 6. That's 4 over x. It's 24 over x squared minus 6x. Alright. So first things first, I need to find a common denominator. This one's all set to go. That's what we need to try and match. So I need to times this by x minus 6. So where to do the bottom, you gotta do the top. Over here, I'm going to do x and x. Alright? Because when I distribute both those through, I'm going to get the same thing as the bottom of the right-hand side. So I distribute my tops. I get 6x squared minus 4 times x is 4x. 4 times negative 6 is negative 24. Plus 24 because negative, negative. The negative has to hit both. All over, who cares? Because my bombs will be the same. So once that happens, who cares? Bombs don't matter. I subtract 24 over to both sides because it's a quadratic, so I need to get it equal to 0. So I get 6x squared minus 4x equals 0. Both these have an x in them, so I can pull out an x. 6x minus 4 equals 0. So this tells me that 0 is 0. I set each piece equal to 0. Actually, you could have pulled out 2x if you want to make your life easier. Oh well. I set this piece equals 0, and I get 6x equals 4. X equals 4 over 6. Or 2/3. So those are my two answers. But when I plug in 0 to my original equation, that's undefined. So scroll down. So my only actual answer is 0. Alright? Or is not 0. I'm sorry. 2/3. 2/3 is my only actual answer because 0 gave us an undefined because you can't divide by 0. Alright? Alright. Alright, let's keep trucking. Alright, growth or decay. Find the factor. Well, it's a decay because it's less than 1. To find the factor, you do 1 minus what that number to the x was, which gives you 135 points, so it's 13.5%. Alright? Number 17. By rule, log base, I don't know, let's say a of x equals b means a to the b equals x. So for this one, we get 4 squared equals x. Alright. For 18, we take the log of our top number and divide it by log of our bottom number. That's change of base formula. Okay, and when you do that, you get about 0.689. Oh, I said 4. 686. Same forward and then backwards. Alright. 19. 8 natural log x plus 2.8 equals 12.8. Alright? So, divide by 8, divide by 8. Alright, 12.8 divided by 8 is 1.6. So I get natural log x plus 2.8 equals 1.6. Now, how do you get rid of a natural log? You take them both as a power of e. Okay, so when you do that, that cancels. You're left with x plus 2.8 equals e to the 1.6 power. Now, this question, I would rather you do an exact answer, but ask for approximate. So we'll do that. So I'm going to subtract 2.8. And you plug that in your calculator. Oopsie snoodle. Plug it in correctly. X equals 2.15. Alright? Alright, last question. I'm going to put all the trig stuff on part 2. Alright? So I'm going to use the formula P times 1 plus R over K to the KT. Alright, but now since it's compounded quarterly, my K is going to be 4. My principal is 6,100. That's what I started with. 1 plus my rate is 0.124 over my quarterly compounding. And I'm solving for t. I set that equal to, want to know when I'm going to have $7,600 and be able to retire. Woo! So first thing I do is divide by 6,100. Zeros cancel. Right? So what's 76 divided by 61? Nasty decimal, so I'm going to leave it. Now, I need to get that exponent down so I can actually do this problem, right? So I natural log both sides. You could also use log. Then I can move that out in front. Okay? What is 1 plus? What? You're wrong, calculator. So it's 4t times natural log. I just changed that top part to a decimal so it's easier. And it doesn't repeat. So I divide by 4 times natural log of 1.031. That cancels, the 4 cancels. So I get t equals, drum roll, I better hear it. I got 1.8. Alright, make sure and check me, make sure I did it right. That's it. Bring in your questions on Monday. Have a good weekend.